Okay guys, this is video 2 of our pre-lab lecture about topographic maps. So as you can see here, I have a topographic map, also by the USGS, which your map is too, the U.S. Geological Survey. The USGS is a government organization that produces a large number of maps for us all across the United States, topographic and otherwise, okay? So as you can see, if you look over here in the right corner, that this particular map is from Fairbanks, Alaska. All right, so yours is from Utica, New York. This one that we're looking at today is Fairbanks, Alaska. So let's look down here at the bottom of the map. Let me zoom in a little bit. Okay, so down here I wanted to show you the scale. So actually there is a bunch of scales here, right? So these ones down here are bar scales. So you can see this first bar is 4 miles. There's one here for feet and one for kilometers. But we actually want to take a look at this scale up here. Now, if you take a look, it says that it's 1 in 63,360. Now, notice that this does not have a unit. All right, so that means that you can put the same unit on either side of this and the statement would be true, any unit of distance. All right, so 1 centimeter on the map would equal 63,360 centimeters on the ground. Okay, this is also true if you said that 1 inch on the map equals 63,360 inches on the ground. Okay, so that's how you use your scale. Also down here, notice that we have our contour interval is 50 feet. We're going to talk a little bit more about that right now. Let's just go ahead and take a look at part of our map. Yeah, so over here, as you can see, there's lots of lines here. And if you look, this one here says 750. Actually, let me back up. So each one of these lines here are called a contour line, all right? And they connect places with the same elevation. All right, so any line around this on this 750, any land that lays on this line is at 750 feet above sea level. All right, and all along this line. But what if we wanted to look at a line that doesn't have a number, right? So a bunch of these lines don't have a number. That's where our contour interval comes in. So let's say that we wanted to take a look at this line that is right to the right of the 750, right here. And so we know that with a contour interval that this number is either going to be plus 50, so 800, or minus 50, so 700 feet above sea level. But how do we know which one is which, right? So how do we know if it's 700 feet above sea level or 800? Well, we can see that this dark line right, so we can look at these dark lines. This one says 1,000, right? If we look at this one over to the left and we follow it around, we find the number, we see that this one is 500. So we know that all of the lines on this side of the 750 dark line is ascending. Their numbers are getting larger, right? So it's climbing in elevation. All of the numbers that are to the left of the 750 line are descending. They're getting smaller, right? Or they're lowering in elevation. So we know that this one, since it's to the right, that it's actually 800 feet above sea level. Okay, so let's look at some color and symbology of a map. First of all, we have brown areas and we have blue areas, right? So the brown areas you can probably guess are our land areas, and the blue are our water areas. Okay, and that's almost universal through all kinds of maps. Not always, but many maps use that color scheme because we can make sense of that in our mind, right? Land is often brown, like soil, and water is blue. So we often portray that in maps as well. You can see a bunch of different types of water features here. We have a lake, Dead Man Lake. We have the Tatana River. All right, but you can also see over here to the right-hand side that we have a marshland. Okay, so we can portray water features like that as well. So let's take a look at some of the land features that we have. So let's start back at the marsh area. So marsh is actually a mixture of land and water. Okay, there's a lot of vegetation in this area, and so it's portrayed as brown, okay, a brown background. But you can see all of these icons here that are representing the wetland. Okay, so these are areas where there is a particularly large amounts of groundwater, but perhaps you can step through it or something like that, something like a bog, okay? Then we also have mountains, right? So we would expect that a bog would be pretty flat, right? Because water is laying on top of it, and we know that water always lays level, right? Land does not always lay level, right? Because it's a solid, whereas water is a liquid. So we also have these mountains over here, and we can tell that these are mountains kind of because you see they have like a little circle in the middle, and they have radial circles coming out around it. Okay, you can always see that this little X here is the highest point of the mountain or hill peak. So this one here is 1,190 feet above sea level, and everything would be descending. All the areas will be descending around it. Once again, over here, this is more like a hill, right? We have 614 feet above sea level as the highest peak, and then it goes down for about 150 feet. Okay, so we also can see how steep a slope may be by using these contour lines. So let me erase this. So if we're going to take a look at the area between these two contour lines, we'll see that these three altogether are very far apart versus some of these over in this area, right? So when you see that two contour lines or many contour lines are far apart from each other, what that indicates is that it is a very gentle slope, right? Or even maybe near flat. And that's because we have over this whole area, it only rises 100 feet. Okay, whereas if you're looking at contour intervals from here and here, okay, we have 100 feet rise in this small area. Okay, so we can understand now that this would be very steep, where this one is a very gentle slope. Okay, and in fact, we kind of see where the that there's no contour lines or very little contour lines. See, there's a little bit down here in this marsh area, and so that kind of goes back to the fact that we know that marsh areas are relatively level land, right? Because the water sits level on top of it. The last thing I wanted to show you guys really quickly is about okay, so we can actually, using topographic maps, see how the river flows. So here is our river that we're going to look at. And if you look at the contour lines around it, you can see that they all kind of make these little arrows going along the river, right? And we can see that they all go this way. And what that does is, you can remember that the arrows point towards the source. All right, so that means that somewhere here there is probably some groundwater that comes out of the mountain and runs as a stream. So it's starting up here and it's actually flowing southwest going this way, okay? So the arrows point towards the source and opposite the way that the water is flowing. Okay, is that about it for my pre-lab lecture? I forgot anything, but if there's anything that you want to talk about as far as topographic maps, if you're a little bit confused on one of the questions of the lab, make sure that you come into my office hours. I have 2 hours a week for every class, so please utilize them. All right, guys, I'll see you next time.